So on this first one, do you guys remember how we graphed this one? Y equals negative x. What kind of,
Y equals,
That's
it starts on origin, goes down one over one.
right, this is basically a linear equation and it's in slope-intercept form. Linear means what?
Line.
Line. It'll make a line and it's in slope-intercept form. What's the slope?
rise over run.
1. Negative 1.
Never mind.
What's the y-intercept?
0.
0. Okay, so there's kind of two hidden numbers there, the slope and the y-intercept. And so the y-intercept is 0, that means you would start at 0, and then you go down 1 is the rise, 1 is the run, so it goes down 1 over 1 like that. Whoa. Anyway,
That's a great line.
makes a diagonal. Yeah, it's like a Jordan line. Okay, and then y equals 2. I'll stop there. Y equals 2. What did that line look like?
It's just a vertical. No, it's a horizontal line.
Yeah, you go up to 2 on the y-axis and just draw a horizontal line to that.
It's actually a 2.1. You missed.
Huh?
Thank you.
It's like above the 2 line, so it's like
Okay,
2.1.
thank you, David.
Maybe you missed it, why?
Okay, how about x equals negative 1?
It's a vertical line at negative 1 on the x-axis.
Yeah, so you go to negative 1 on the x-axis and draw a vertical line.
No.
Which of those three is not a function?
The x equals negative 1.
Yeah, why is this not a function?
It's undefined and it would, like, if you did the vertical line
No,
test,
slope.
it would hit all the
Yeah,
points.
that's true. Yeah, it fails the vertical line test. It would hit every point, not more than 2 points for sure. All right. Now we haven't done this year, but you guys know what this graph would look like? Like the left side is.
Is it like
Would it just be the
would it just be
origin?
starting at 0
It
and
would-
diagonal line going up?
Be the origin.
Kind of.
I thought.
Okay, let's play a little game here. What if I plug in 0 for x? What do I get for y?
0.
What if I plug in 1 for x?
Then y. It's 1 1.
I plug in 1, I get 1. If I plug in 2,
You get 2.
I get 2. So this part's the diagonal. What if I plug in negative 1?
It would be 1.
I get absolute value of negative 1 is 1. So y would be 1 in that case. So negative 1, 1. If I plug in negative 2,
It'd be
For
positive
x,
2.
I get positive 2 for y, negative 2, 2. We did this in Algebra 1. You guys remember?
Yeah,
It's almost like a parabola or something.
It's not a parabola.
What's a parabola?
It's a V.
It's a parabola.
What makes a parabola shape? We're kind of going to talk about this later, but
Oh, okay.
y equals x squared makes a
What?
parabola.
What's a parabola?
It's like the curvy ones.
It's,
Oh yeah, that's the dip, like the bowl or whatever.
Yeah.
Or the U. Yeah.
You just think you're stupid.
No.
All
Okay.
the time.
Here's a question that we probably forgot. What if I, instead of just putting x right there, actually let me do this. What if I put a little +1 outside?
And you
It
move
goes
it
up
up.
1.
The graph goes up 1.
It's like that. It looks like number 8,
I'm
right?
the best.
You can't see number 8, but if you could, you'd agree with me.
No, Nick.
Are you on?
What page are you on?
No,
No,
it's a V shape.
What?
We're talking about absolute value of x, it's this shape. So if you put a +1 up there, it would just go like this. It'd just be 1 higher.
It's not
Everything.
even.
David's like harassing me that I was wrong.
Line.
Okay, what if I put a +1 inside the absolute value?
Then
Then
it goes
just
to the side.
The X would be
And it goes to the right one.
just the X value.
Okay, actually it does the opposite. It makes it go left 1.
Left one. I said that.
Yeah.
Oh.
So,
Oh.
or is it only the, don't tell me it's just the juniors that remember this stuff.
I remember.
I don't even know.
I don't remember all of
Didn't they
it.
do
but
I just need
just a little bit.
clarification.
You guys were in the same class last year, and just different times.
Yeah.
Okay, this makes it go up 1. We're not really focusing on this today. I'm just trying to remind you. This is not really what it's about today. This makes it go up one, this would make it go left one. Anyways, absolute value.
Yeah.
Cool.
Oh, wait. That was 2 years ago, not last year, my bad. So that was quite a ways to remember. All right, we got 2 new ones that are weird. Let's start with this one.
Is it the curvy one?
Whoops, that's too big. Okay, I think they call this like the greatest integer function.
Yeah.
Do you see that written somewhere?
Yeah, it's C for the first section.
Yeah, here it is. They call this the greatest integer function. What it does is it basically, whatever number that you put in for x, it rounds it up to the next integer. So it never rounds down, it always just goes up to the next integer. So, well, if I'm here, this is function notation. Okay. So if I put in f of 1, so if I put in 1 for x, it's still going to be 1. Not going to change it. But if I put in like 1.5, it's going to round it up to a 2. Guess what if I put 1.2 in there?
Round to 1. Or would it
Round it up to a 2. Okay? So it just moves the number up to the next integer.
Why?
It just comes in handy sometimes. They have these programs on computer programming, just it's useful sometimes.
Back in the day.
When you become a computer programmer. That's when you're doing it.
That's not gonna happen though, so.
Okay, now here's a trick question. What if I plug in negative 0.5?
Nothing happens.
Whoops.
It's 0.
0. What if I plug in negative 2.4?
Move around to 2. Negative 2.
Negative 2. Because when you're rounding up, negative 2 is actually higher than negative 3, right?
Mm-hmm.
So if you round up on the negatives, it actually goes backwards, right? It goes to negative 2. This goes to 0. This goes to 2, 2, 1. Got it? Does that make sense?
Oh,
What's the graph look like?
Oh.
Okay. If I plug in, let's make a small graph. If I plug in negative 2, I should get negative 2. So I guess that looks like that. That's kind of gonna screw us up. If I plug in like 1.9 or negative 1.9, no, I said that wrong. If I plug in negative 1.9, that should round to negative 1. Gosh, this is hard. Let me just draw it and then I'll explain it.
Are we on?
Let me draw it and I'll explain it. Okay, you guys see like negative 2.5 would be right here, right?
How old are you?
Negative 2.5 should round up to negative 2. So that's negative 2.5, negative 2.
Yeah.
If I plug in negative 1.5, that should round up to negative 1. So it's negative 1.5, negative 1. If I plug in negative 0.5, it should round up to 0. You guys kind of see where I'm getting at here.
Mm-hmm.
So it's stair steps because all these decimals would round up to negative 2. All these like negative decimals. And then once you get to negative 2, it starts bouncing. Everything past negative 2 this way bounces to negative 1. I don't know. It's kind of hard to explain. But they all round up to the next integer.
Do we have to do this today or look at it?
Well, we're going to need to know what it looks like at least.
Wait, so what was that? Was the greatest integer? The one where it rounds?
Yeah.
Okay.
It rounds it up to the next greatest integer function.
Okay.
looks like this. Looks like this with the little brackets around it. Okay, and the last one is the trickiest of the tricky. Piecewise function. I could make one up, but it would probably take me too much thinking. I'm gonna steal one from the book.
You're gonna give it back, right?
That was bad. Yeah.
That was an awesome joke.
That was.
R.I.P. Austin.
You guys want me to go back to speaking Spanish?
Yes, please.
No.
Yes, do it.
Soy I'll go on this one.
I was
Wait.
You should
Tú es muy bueno.
Holy crap! What? I look away for 2 seconds and you have a.
Okay,
Where'd that come from?
so I'm done writing. On this one, they basically cut and paste 3 different functions together in one. So from x equals -5 to -2, 1, 2, 3, 4, 5. So from here to here, you're doing f of x equals -3, which is like y equals -3. What does the graph y equals -3 look like?
It's a.
Horizontal line to
Yeah.
-3 on the y-axis. So from -5 to -2, it's -5 is included and -2 is not included. Do you guys see what I'm saying?
Yeah.
Because this is equals to, this is not equals to. So I'm going to draw a filled in circle at -5, an open circle at -2. Okay, that's what's happening from -5 to 2. From -2 to 1 is the graph y equals x plus 1. So that's from here to here. So y equals x plus 1 has a 1 slope, right? And an intercept, a y-intercept of 1. So it's right there. The slope is 1, so it would be right there. Right there. And then it stops at 1, so it would be like that. That's y equals x plus 1, but I just drew the from -2 to 1 on the x-axis. Then on the last one, kind of same thing, from 1 to 4, 2, 3, 4, it's going to be -x plus 4. So you go up 4 for the y-intercept, but I'm not going to draw back there. And then down 1 and over 1 for the slope. So down 1, over 1, down 1, over 1. Basically -1 slope. Did I get that right? My picture's not very pretty. 1, 2, 3, 4. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Yeah, that's basically it. There we go. You guys kind of see what they're getting at. So I didn't draw all the way back to 4 because you're supposed to start at 1. But I started right there instead of right there. And you just kind of hook them all together. Except Frankenstein. Does that make sense? Just 3 functions cut and pasted together in different parts of them. It doesn't have to be 3. It could be 2. It could be 1,000,000. You can do 1,000,000 functions together. Okay, you're good. You don't want to do that? Okay, number 1. We'll talk about 7. We kind of did something like 7. I want to say it's third. I don't know. Sometime last week. Maybe it was a Tuesday last week or something. Number 1. What kind of function is that?
Absolute value.
Absolute value function. So on 1 put A. Number 3. What did I call that function?
Greatest integer.
Greatest integer, so 3 is C. Number 5. I have to look at the options to figure that one out.
Constant?
A constant is just a number.
Isn't it?
Oh, wait, is that linear? Or?
Yeah,
Okay.
it would make a line, like a diagonal line with slope of 1, y-intercept of 0. So that's a linear function.
Jessica, you should try and say the answers faster.
No.
Okay, number 7. We did a couple of these last, I think, the beginning of last week. The domain is the what?
X value.
The x values. So remember on the graph, the x values go from left to right. So what's my smallest x value on number 7? I have to, it's kind of hard for me to count.
-6.
-6, right? Okay, so this is how we did it. We said x is running, so domain equals, it's going from -6. Is -6 included?
No.
No, because of the open circle, so I'm just going to put less than x. And then what's the largest x value? 2. Is 2 included?
Yes.
Yes. So all the x values are everything between -6 and 2, with 2 included. The range is kind of the same thing, but range is y value, so it goes from down to up.
-3, 2.
The smallest y value is -3. Is -3 included?
Yes.
Yes, because it's hitting the line at -3. What's the largest y value? How high does it go? 6?
Check it out, but not like last time.
I know, that's what I was thinking. Yeah, it is 6. Is 6 included?
Yes.
Yes. Okay, number 9, this is where it gets a little hairy, a little messy. Okay, does 9 have continuous x values from
No.
left to right?
Mhm.
Actually, it does. The x values are continuous, starting at what though?
Starting at -6.
Starting at -6, is that right? Yeah, it is. It does start at -6. Is -6 included?
No.
No.
No. So I'm going to put -6 less than x, less than, how far does it go to the right? 3. Is 3 included?
Yes.
Yes, because the circle's filled in. Yeah, all those x values in there are completely connected. Does that make sense? Like you can go from left to right, like drag your finger across left to right, there will be a point at any of those x values between -6 and 3. But the range is a little trickier because there's breaks in the ranges. If you're going down to up, there's some jumps you have to make. So what we're going to do is each section at a time. So what's the lowest y value on number 9?
Negative or positive.
+1. And then, how high does it go from there? No. Okay, it doesn't go all the way up to 4 because it's not a continuous set of points. Yeah, it goes up from 1 to 2. Is 2 included?
Yes.
Yes. Okay, but there's nothing between 2 and 3, right?
Yeah.
There's no y values between 2 and 3.
So do you do +1? Or
What's the next y value?
3.
3. And then at that y value, that line is all on 3. That, like y equals 3 at that point. And then there's nothing between 3 and 4. But there are y values at 4 as well. Did they put a comma between these? No, they just said or. I guess that makes sense. know these can be tricky. If you have questions, you can ask. 11. Evaluate each function for the given values. Okay. These are weird ones. They're just kind of trying to throw some curveballs at you, see if you can hit it. If f of x equals 5, what happens when I plug in 3? Find f of 3.
15.
No. Okay, it would be 15 if it said this, right? If they said what's f, find f of 3, 5 times 3 is 15. But it doesn't say that, it just says f of x equals 5. So if x is 3, what is the function going to equal? 5. It doesn't matter what you put in for x, it's just telling us the function is going to equal 5. This is the flat line, like y equals 5. It's always going to be 5. So, anyway, I guess the answer is f of 3 equals 5. And what is f of, still in the same problem, what's f of negative 1?
5.
5 also. If there's no x in the function, you can't really change its value. It's just going to stay 5 forever. Forever and ever. 13. H of x equals greatest integer function of x. So h of negative 3.2. You guys remember how we did this? Negative, right, rounds up to negative 3. I don't know if it's really called rounding since we're not going to the nearest integer, we're just making it go up every time, but. And then h of 7/4, this one might confuse us. You guys know what 7/4 is as a mixed number?
Yeah, 1 and 3/4.
1 and 3/4. So if we round that up, 2.
2. Yeah. Don't worry about it.
$15 is kind of the same thing, but you subtract 0.5 first and then you round it up. So on 15, if I put in negative 1.5, what's negative 1.5 minus 0.5?
Negative 2.
Negative 2. So G, and that would round up to negative, well, it wouldn't round at all, but it would just stay at negative 2.
In the book it says that on the greatest integer functions that it's supposed to round down, and in the back it shows that, like on 13 it's negative 4 instead of negative 3.
Oh, you're right, it is rounding down. My bad. Whoopsie. Okay. Yeah, let's just leave all those answers that we had done. So, you're right. I rounded the wrong direction. It's rounding down. But I don't want to go back and... Oh, these are the only ones we did, though.
And 11.
That was a different kind of function. And this one would still be negative 2. Okay, now 15, second part, 5/4. What's 5/4 as a mixed number? 1 and 1/4, so if we round it down now, what's it round down to?
Negative 2. Wait.
1 and 1/4, rounds down to 1. Okay. Numero. Oh, I forgot to subtract though. We were supposed to subtract. So 1 and 1/4 minus a half is 3/4. If I round 3/4 down to the next integer, it would round to 0. Are you guys following with this?
Yeah.
So
Only
do
the juniors give me feedback. Yeah.
Do you always round down, or?
Yeah.
Oh,
Always,
so we were
always
just
down. It doesn't matter what it's closest to. It's always down.
Okay, so it's
I thought
not
it was always up, but it was down.
good.
There probably is an always up function, but Maybe not here. Okay, 17 and 18 is graphing. And I'll do 17 with you guys. And I'll give you guys the graph paper. How we doing on time? We got 2 minutes? That's about right.
You guys use the graph paper for just like two problems.
I'm gonna give you a half sheet of graph paper. I don't want this. Man. Yeah, I'll need a half sheet.
Alberto and Pablo.
I don't want the sloppy Joe.
They're running. What's that supposed to know? Something against running?
What are you like, gonna do this whole C in finals?
No, just three. They're just fine. I don't know actually. I drew this one. Then I drew this one. That's a lot of graph paper.
For 2 problems, yeah. There's kind of 2 sides to this graph paper. One side's dark and one side's light. I think the lighter side works better because you can see it better. Okay, number 17 says graph
Oh, yeah, here. Graph each function of the
absolute
state.
x plus 2. Alright, here's how we're gonna do it. There. Well, we kinda already talked about what this is gonna look like, but I want you guys to put in like 5 x values and find out what y value comes out. So let's put in -2 through 2. If I plug in -2, what do I get?
0.
-2, absolute value of -2 is 2,
Oh,
plus 2 is 4. If I plug in -1, absolute value of that is 1, plus 2 is 3. If I plug in 0, 0 plus 2 is 2. And if I plug in 1, 1 plus 2 is 3. If I plug in 2, 2 plus 2 is 4. There's kind of some symmetry there. It goes 4, 3, 2, 3, 4.
Mm-hmm.
So that's where it bounces into you. So -2, 4. Hopefully you guys remember how to graph those. You go left 2, up 4. -1, 3. Left 1, up 3. 0, 2. 1, 3. 2, 4. Should be perfect diagonals.
Unless you're Jordan.
Mm-hmm.
Unless you're Jordan, then they won't look like perfect diagonals.
Like I said, Mr. Gordon.
I don't know who talked to you.
Jeez.
Wow.
Can we use the same max values for the next problem? Or? Shut up, Jordan. I didn't know.
Actually, there might be some better ones to use. So on the next problem, do you guys remember what I said that -3 would do inside the absolute value?
Move it right.
Yeah, it moves it right 3. So since right 3 will be like the middle of the graph, you might want to choose. Whoops, you might want to choose x values around 3. So like 1, 2, 3, 4, 5. Those would be some good x values to use.
So for 18, let's say you put 1 into the equation, so it'd be 1 minus 3. But would it be like adding 3 because you're moving it right, or?
No, you just do what it says. 1 minus 3, whatever that is, and then take the absolute value.
Okay, so it's positive.
Wait, so Jessica,
Yeah.
if you just did 1 minus 3 for 18, it would just be
Stop.
positive
5
2,
minutes.
right?
1 minus 3.
Yeah.
And that's the value, and that makes it positive 2.
Yeah, it's positive.
Okay, so then what do you do with this?
Well, that gives you your ordered pair because you already had the x value, but that running it through the equation gives you your
Okay, so
y.
you have 2 now, what do you do for x with y?
Well, you get to pick the x's. Like he said that once you do like a little cheat.
Right, okay, so x is 2,
Yeah.
what's y?
So you would run it through the equation, so 2 minus 3,
Okay,
that's
so
negative
everybody
1,
finding
absolute
this
value
book,
makes it
remember that.
positive 1, so positive 1 is the y value.
Yeah. So someone made dots. So you
What's x?
The one that put in.
can rise over.
Yeah.
So the next one
So you
will.
can put x and y value?
No, you pick the x values, and the x values you pick are the numbers that you put into the equation, and that's what gives you your y
So
value.
then how do you get y? You just go 1 to 3.
No, Jordan.
Well, you have to write,
So
yeah, you have to write slope.
this is right.
Okay.
But
You
you have.
got to run the y-intercept. So you can't go see the y-intercept. So what we did to find it on this one was we just plug in slope.
So you put 2, right? You put 2 in here.
Right.
So 2 is the x.
Okay.
2 minus 3
Goes in, you know,
negative 1.
and then that
And then you add 2 values to that, so you get 1. So you get y is equal to 1.
looks like you did it.
So that's 1 here. But if I did
So,
3 minus 3, 0, absolute value, 0, 0, and then y equals 2. So it's 0.
You did 5, so it's 5 minus 3, that's 2.
It's 5 minus, yeah, 5 minus 3.
And it's
And
5
5
is
is here, and that'll be 2.
So
Y
if I
equals
can
2.
Yes, I don't either.
The y is,
oh, and then standard.
this, whatever you get there, this is y. Y is this y.
Like since last night, yes.
They're the same y.
No, it isn't.
This is the same as this is the same as this.
I think you might have got that right.
So you put,
It's like 5 minus 3, that's 2.
yeah.
So that's your x,
So on
right?
this one,
No, 5 would be your x.
you got
2 would be your y. Because 5,
Okay, I got it.
I'm zooming, dog.
you have a try how fast can you go?
What? I'm like 11 team.
I'm about like 4 blocks and stuff.
Yeah, okay, I got you.
that goes for the slope.
Like, okay. But, I mean,
The X line.
I don't know, I'm probably like 11 teams to like Jonestown, I don't really know.
Yeah, I would say like Salem to like.
Yeah, no, okay. Maybe like filing cabinet to Holocaust.
Okay, parallel lines have the exact same.
Maybe like
So you need a
child sacrifices, like rainbows.
Oh, I got you.
Yeah.
Somebody needs to put them.
Perpendicular lines. Do you remember the slope of this?
Pretty sure if I talk to them, probably lose brain cells.
Yeah.
Perpendicular lines.
I'm gonna do both.
Opposite reciprocal.
I don't know.
And they're just opposite. So, on the last part, it doesn't have any spots, and it's 1/3. So use 1/3 for your slope.
How much time do we have?
That's
How much time do we have?
Actually, it'd be negative 2.
What?
Are you good? So we're good? Okay.
So
No phones in class. Jordan, you need to show work. Killing the grade. You need to show work.
yeah, that's what the challenger did.
Teacher's challenge was like,
Yeah, what's being challenged now? Your life? Imagine. Yeah.
You gotta remember that.
You just don't do
Yeah, you're gone. She was gone like one day, and then you were gone the next day. So.
We were gone the same day, but like, as soon as she got back.
I'm gonna be gone, well, all three of us will be gone Wednesday and Friday. You're both Wednesday.
Okay, I'm trying to record it. Have I been recording this? No. Whoopsie.